So these next problems are quite a bit more difficult. Again, you want to clear the parentheses first and then get rid of any negative exponents, and then you're free to do your exponent rules in any order you want. So on the first problem, we want to get rid of the parentheses by taking the squared exponent and applying it to all bases. Don't forget that 3 is a base. So we have 3 squared, x to the negative 4, and y to the negative 6. On the next parentheses, we also have an exponent, so we need to apply that exponent to all 3. So that gives me 5 to the negative 3, x to the negative 3, and y to the positive 3. Now that we have that done, I'd like to get rid of the negatives by making everybody positive or happy. Remember that rule for happy? So I'm going to make a fraction bar because it looks like some of these are going to be going in the fraction bar. I'll start with my red. The red 3 to the x was in the numerator, right? Because all of these were numerators. So he's happy where he's living, so he's going to stay in the numerator. X to the negative 4, he's not happy where he's living. He was living upstairs, but he wants to live downstairs. The other thing that I'm going to do at this moment is I'm going to sort my numbers to go in the front, my x's to go in the middle, and my y's to go in the back. So then when I have y to the negative 6, who was living upstairs, he's not happy about it, I'm going to move downstairs. In the blue, I have 5 to the negative 3. Because of the negative exponent, that means he's not happy where he's living. He was living in the numerator, so I move him downstairs. X to the negative 3 needs to move downstairs as well. And y to the positive 3 was happy where they're living, and they were living upstairs, so they stay upstairs. And you see how I kind of organized the numbers in the front, x's in the middle, and the y's at the end. It's just there to help me not to make any mistakes or forget anything. So on the numbers, I have 3 squared on top, which is 9, and 5 cubed, which is 125. On the x's, I have 2 x's downstairs. Because they're right next to each other, side by side, that means you're going to add your exponents. I have 2 bases and 2 exponents. That means add. That's not multiply. Up here, when we distributed our 2, that was when you multiplied the exponents. But when you have 2 bases and 2 exponents, that's when you add them. And then on the y's, I have 3 y's in the numerator, 6 y's in the denominator. You're going to subtract your exponents, so that gets me 3, and the leftovers are going to go in the denominator because that's where the more y's were to begin with. On our next problem, we're going to clear the parentheses first by taking the negative 2 and distributing it, which gets me 3 to the negative 2, x to the 5 to the negative 2, 1 base and 2 exponents, that's a multiply. Y to the negative 4 to the negative 2, 1 base, 2 exponents, that's a multiply, and I get positive 8. In the denominator, the 3 goes to all 3 bases as well, so that gets me 2 cubed. X to the negative 2 to the 3, 1 base and 2 exponents. That's 1 x base and 2 exponents, that's a multiply. Y to the negative 3 to the positive 3, again 1 base and 2 exponents, that's a multiply. After I've gotten rid of the parentheses, because that's the first step of PEMDAS, I need to make all of my exponents positive. So my red numbers in the numerator, 3 to the negative 2 is going to move downstairs to become happy. X to the negative 10, he was not happy where he's living, so he's going to move downstairs. And y to the 8 was living upstairs. They're happy about it, so they're going to stay there. In the blue numbers, we have 2 to the 3 that was already downstairs. They like being downstairs. There's already positive or happy, so he stays there. X to the negative 6 was downstairs. He's negative. He's not happy about it, so he's going to move upstairs. And then y to the negative 9 was downstairs, but he wants to move upstairs. So once I've got all of my negative exponents turned to positive, then I have less room for error there. So let's do the numbers first. 3 squared is 9, and 2 cubed is 8. Do my x's, I have 6 x's on top, 10 on the bottom. After you cancel or subtract your exponents, you get 4, and the leftovers are going to be in the denominator. Then I have y to the 8, y to the 9 in the numerator. Both of them are in the numerator. Notice I have 2 bases and 2 exponents. That's when you add your exponents to get 17. You wouldn't multiply because you have 2 bases and not just 1. So this leaves me with y to the 17 over 72 x to the 4. On our next problem, the first thing you want to do is get rid of the parentheses. So this 2 is the exponent for the parentheses, because the parentheses is a thing right before the 2. And because we have a lot of things in there, it's going to go to all bases in the numerator and all bases in the denominator. So just first get rid of the parentheses. Don't worry about the negative exponents at all. We have 5 squared x to the 4. Notice I'm multiplying those exponents because I have one base and two exponents. Y to the negative 10. On the denominator, I have 8 squared x to the 12, y to the negative 24. So now that I have the parentheses cleared, I would like to deal with getting rid of any negative exponents. So on my red numbers in the numerator, 5 squared, he had a positive exponent, he stays put. X to the 4 had a positive exponent, he stays put. Y to the negative 10 has a negative exponent, so I'm going to move him downstairs to make him positive or happy. On the denominator, I have 8 squared was positive exponent, so he stays. X to the 12 had a positive exponent, so he stays. And y to the negative 24 had a negative exponent, so he's going to move to the numerator. Once I have all of my negative exponents become positive or happy, then I have to work with the numbers, the x's and the y's. So for the numbers, 5 squared is 25, 8 squared is 64. For the x's, I have 4 x's on top, 12 on bottom. After you divide those out, or subtract your exponents, you get 8. Where would the leftover 8 go? On the bottom, because that's where the bigger number was. And then I have 24 y's on top, 10 y's on bottom. After you cancel or subtract your exponents, you're going to be left with 14. I leave those 14 in the numerator because that's where the larger number was. On this next problem, the first thing I want to do is clear the parentheses. So that negative 3, which is being applied to the entire parentheses, has to go to every single base in the numerator and the denominator. So for the numerator, I'm getting 6 to the negative 3, x to the negative 9, because we have one base, two exponents, that means I'm multiplying, and y to the positive 6, because a negative times a negative is a positive. In the denominator, I'm getting 9 stays the same. The thing that you're multiplying is the negative 3 times the 0, because you're multiplying the exponents. So that gets me 9 to the 0. X to the negative 5 times negative 3, that's positive 15. Y to the negative 6 times negative 3 is positive 18. So we have 6 to the negative 3 is negative, so it goes downstairs. X to the negative 9 was upstairs. It's not happy living there, so you're going to move it. And y to the 6 was happy upstairs, so you're going to leave him upstairs. Now, 9 to the 0 is happy where it's living, but we know 9 to the 0, that's just 1. So we can put that 1 here, because anything to the 0 is 1, so 9 to the 0 is 1. X to the 15 is positive exponent. He's happy where he's living. You leave him there. And then y to the 18, again, is positive exponent. He's happy where he's living. You leave him there. So then let's clean up the numbers, then the x's, then the y's. For the numbers, I'm getting 6 to the 3. That's 6 times 6 times 6, which is 36 times 6, which is 216. For the x's, they're both on the same level. They're both in the denominator. Two bases and two exponents says that I add my exponents, which gets me x to the 24. And then on my y's, I have 6 y's on top, 18 y's on the denominator. Because they're on different levels, that means I subtract, and I'm left with 12 y's. The leftovers will go in the denominator, because that's where the more y's were to begin with. And the last thing I need to do, because this is not quite a final answer the way it is to put a placeholding 1 on top. You always have to write something in your numerator. If all of the bases are left in the denominator, then you have to put a placeholding 1 in the numerator. On our next problem, we don't have any parentheses. Yay! So the first thing I should do here is make all of my exponents positive. Now don't forget that 18 has a positive exponent. It's going to stay in the numerator. X to the 4 is a positive exponent, it stays, but y to the negative 3 moves downstairs to become y to the positive 3. In the denominator, I'll do that in blue. I had 12 to the positive 1. The exponent was positive, so it doesn't move. x to the negative 7 had a negative exponent, so he's going to move. He was downstairs, so you move him upstairs. And then y to the 5 stays downstairs because he is positive. Now, 18 twelfths. 18 twelfths can be reduced as a fraction, just like you've done other fractions in the past. And 18 twelfths reduces to 3 halves by dividing both the numerator and the denominator by 6. Both of the x's are in the numerator, so then I'm going to add the exponents to get 11, and then add the exponents on the y's and get y to the 8. So a common student mistake here is instead of taking 18 twelfths and reducing it like you've always done in the past by dividing it by 6 and getting 3 over 2, that's how we've always done it, or there's other ways of writing it, but that's really how you reduce fractions. But what some students will do is, because they know that, I don't know, here's an example. Let's say you have x to the 7 over x to the 2. They know that they subtract their exponents to get x to the 7 minus 2, x to the 5. So this is an exponent rule. Okay? What they'll do in 18 twelfths, which is wrong, is they'll take the top minus the bottom and then they'll get 6. That's totally wrong. What they're doing is they're taking a fraction and trying to apply an exponent rule of it. But again, what are we subtracting here? We're subtracting the exponents of like bases. So the x's have to be the same, and then we subtract their bases, okay? Now, the 18 and the 12, first of all, they're bases. Second of all, they're not the same. And third of all, there's no exponents. So the exponent rule would not apply over here. But some students will do that, so I just wanted to make you aware of it. Okay, on this last problem, we have a negative 2 in the exponent, so it's going to distribute to all of the bases in the numerator and all of the bases in the denominator. I'll do those in 2 different colors. So I have 2 to the 0 to the negative 2. So because I have one base and 2 exponents, that means I'm going to multiply and get 2 to the 0, x to the negative 8 to the negative 2, that's x to the positive 16, one base, 2 exponents, you multiply. Y to the 6 to the negative 2, that's y to the negative 12. In the denominator, I have 5 to the negative 2, x to the positive 6, and y to the positive 8. So on the red, 2 to the 0, that's really just 1, okay? I'm just going to go ahead and evaluate that at the moment so I don't have to keep bringing him down. X to the 16 was positive, it stays upstairs. Y to the negative 12 was negative, so it's going to move downstairs to become positive. In my blue, 5 to the negative 2 was downstairs. I'm going to move it upstairs to make it 5 to the positive 2 because he's not happy where he's living, so you move him. X to the 6 was downstairs and he's happy about it, so you leave him there. And then y to the 8 was downstairs and he's happy about it, so you're going to leave him there as well. Let's go back and work our numbers. 1 times 5 squared, that's 1 times 25, or just 25. On the x's, I have 16 on top, 6 on the bottom, which leaves me with 10 leftovers in the top. And then I have 8 y's on the bottom and another 12 y's in the bottom. Because they're both in the bottom, I'm going to add the exponents. And 2 bases, 2 exponents, I add and get 20. And that's my final answer.